Hello again. For this podcast, we're going to explore a different technique of factoring, commonly referred to as factoring by grouping. Um, if we're at this stage in our factoring experience, we should know that the first rule of factoring is to factor out what's ever common in a polynomial. So if we look at this polynomial here, we see that it has four terms. 1, 2, 3, 4. And if we're looking at all four terms in the polynomial, we see that there's nothing that all four terms have in common. There's nothing we can take out of all four terms. This polynomial is also not a quadratic polynomial. It doesn't have a squared variable, so we couldn't use any type of quadratic factoring that would help this as well. What we're going to do is, instead of looking at this polynomial as a group of four terms, I'm going to look at this polynomial. I'm going to kind of group the polynomial and look at it as two groups of two terms. I'm going to group these first two terms together as well as these second two terms together. So now, instead of a polynomial of four terms, I have a polynomial of two groups of two terms. And now, just kind of isolating each term, just looking at this term, this first term right here, just looking at this one right here, we can see that this first term has a common term of y that can be factored out. So that's what I will do here. I will factor out a common term of y from this first term. And if I factor a y out, I'm left with x minus 2 for this first term. That's supposed to be a 2. It looks a little bit like a z. All right, you have to excuse my handwriting. This plus sign still remains. There's a plus sign in the middle here. That is still going to remain here. And then again, we can do the same concept by looking at this second term in isolation. And looking at the second term in isolation, we can see that the second term has a common factor of 2 that can be pulled out. And if I pull out that common factor of 2, we pull out a 2, we have left an x minus 2 term again. Okay. So now we have another polynomial again. Now, each side has kind of been factored, and you can still kind of look at this as one term here, and this as a second term. Okay. Now, pulling out of what's common in first and the second term, you can see that both terms have this common term of x minus 2. They have a binomial that's the same. This is very different for people in factoring. People are used to just pulling out monomials, or single terms, single variables. But actually now we can pull out this binomial from both terms. So both terms have a common x minus 2 factor in it. So I can pull out that x minus 2. Oops, excuse me. I need my writing utensil here. I can pull out that common factor of x minus 2. And again, what I'm left with from this first term, if I pull out the x minus 2, I'm left with a y here. And notice this will be multiplied because I'm pulling this out as a factor. Factors are always multiplied. I'll be left with a y from my first term. The plus sign remains, that's in the middle here, and then a 2. And this would be the fully factored answer. You know that you're done factoring when everything is being multiplied. All of the plus signs and minus signs are within parentheses so that you know things are being multiplied. And you can check that this answer is correct if you want to FOIL these two binomials out. If we FOIL them out, we get our first term here of xy. Our outside term is positive 2x. Our inside term is negative 2y. And our last term would be negative 4. Which, as you see, this polynomial matches up with our original polynomial, except with these two terms in opposite locations. But you can always add terms in any order that you like. So it's our check works. And you can see that this is a nifty way to factor if no other methods are available.